Kaya and Wonju. Welcome to another video in our series on sequences. We have our learning intention is to establish and use the formula for the sum of the first n terms of an arithmetic sequence. We're going to start off with a history lesson from Carl Friedrich Gauss. He's one of our greatest mathematicians, particularly in areas of mathematics, physics, astronomy, and statistics. A well-known story about him that I was definitely told as a student was that at the age of 8, Gauss was asked by his teacher to sum up the numbers from 1 to 100, thinking that it might take him a little bit of time and he could have a break. But young Gauss, after a few seconds of thought, wrote down the answer, 5,050, and the teacher was blown away. Gauss had learned a trick to do this, or he worked it out on the fly. He knew that if you lined up all of the numbers from 1 to 100, it would look like our number line here. And then if you folded that number line over, you would have the ends meeting. So that would go 1 and 100, 2 and 99, 3 and 98. If you sum each of those pairs, they all add up to 101. And because there were 100 numbers, there were 50 pairs. And so the sum of all of the numbers was 50 times 101, or 5,050. And that links to our topic of arithmetic series, as the sum of terms in a sequence is called a series. So if a sequence is arithmetic, then the series is called an arithmetic series. We use S subscript n to denote an arithmetic series, just like we use lowercase t subscript n to denote a term in a sequence of arithmetic sequence. So we start off with our definition of what a term looks like, which is t at n equals a, the first number, plus n minus 1 times the common difference d. Then we remember from our definition, our series will be all of the terms added together, so t1 plus t2 plus t3 and so on. If we replace that with our definitions or equations, we get the first term is a, the second term is a plus d, the third term is a plus 2d, all the way up to a plus n minus 1d. If we fold that on itself, we get something that looks like this, where we've got a and a plus n minus 1d, a plus d, and a plus n minus 2d, etc. Summing each of those, we get the sum 2a plus n minus 1d for everything. If there are n terms, we have n half pairs. So our series equals n over 2 times 2a plus n minus 1d. The last term, L, is t at n, which is a plus n minus 1d. So we could also write this series as n on 2 times a, the first term, plus L, the last term. So those two different equations are what we'll be utilizing in our problems today. So for our examples, we've got our arithmetic sequence 2, 5, 8, 11. Calculate the sum of the first 14 terms. So we've got our equation there on the side just for reference. The first step is to define all our little values. So a equals 2, d equals 3, and n equals 14. Chucking in our equation. 14 on 2 times 2a, 2, n minus 1 times d, which ends up being 4 plus 39 is 41, times 7 is 301. I definitely checked that with a calculator. Don't expect me to know how to do that off the top of my head. For our second example, the arithmetic sequence is 27, 23, 19, 15, all the way down to negative 33. So it's giving us our last term. So I've just conveniently kept our last term equation here on the sidelines. The first part is asking for the number of terms. The second is asking for the sum or the series. So again, we define our values that we know. A is 27, D, the common difference is negative 4 as it goes down 4 each time. We can use the last term, so we know that t at n is equal to negative 33, which is a plus n minus 1 times d. And then we can solve that, subtract 27 from both sides, divide by -4, and determine n minus 1, and then 16 as our n. On the right side, on our b, we've got the sum of terms. We can chuck that into all that because we now have n. We were given a and l. So very simply, s is 16, it's 16 on 2 times 27 plus -33. 27 plus -33 is -6. 16 on 2 is 8. 8 times -6 is -48. You can confirm this if you want to use your calculators. I did it earlier, so it might still be up. So a(n minus 4, where a1 is 27. I believe I've already set it up. So we can see in this one, behind my beautiful face, the last term was -33, first term was 27, and the sum of 6 at 16 was -48. So that's correct. All right, next. Move you back down. Our next one has two parts. The last part is quite long. So first is the sum of the first 25 terms. We're given a is 3, the difference is 3, and n will obviously be 25. And so we just chuck that into our equation, and then we can solve with our calculator, because that is an absurd equation to do off the top of your head, or written 975. You can again confirm that with your calculator if you wish. The second part, s at n, so the series at n is 1395. We can chuck into our equation, so s at n equals 1395, which is equal to n on 2 times 2a plus n minus 1d. I've already substituted in the values we know. I've already worked out what 2 times 3 is, because I'm a genius. And then I have multiplied by 2 and expanded the brackets. So 6n plus 3n times n is 3n squared. Minus 1 times 3 is minus 3 times n, 3n. I also doubled it, but doubled everything to get rid of that 2. Divide everything by 3. Nope. I put it into the same side, then divide up everything by 3. And because I'm a genius who also has a calculator, I know that that is equal to n plus 30 times n minus 31. I did cheat and used a calculator, which is n. We know that n has to be greater than 0 because it starts at 1. And so 31 is our answer for that one. Hope you've enjoyed that. A secret challenge of the week is to give Mr. Barker a high five. Don't let him know. I want to see how long it takes him to find out why he's getting high fives. Enjoy.